All right, so this video is going to be short and sweet. It's talking about LeChatelier's principle, which is basically looking at a system that is at equilibrium. What happens when some sort of change is imposed on that system? If that change influences the reactants and products that are making up that system, the equilibrium will shift to reduce that change, to reestablish equilibrium. So some effects of changes that can impact your chemical system. Changing in concentration. It could be adding one of the components that provides a source of your reactants or your products, or it could be something that removes one of your reactants or products, or the amounts of those. If you're adding towards one of them, you'll shift away from that added component. If you're adding something that removes one of the components, you shift towards that. If the component that's being added is not a part of your equilibrium expression, then there won't be any change. Temperature will cause a shift in your equilibrium. It can also cause a shift in your equilibrium constant. It acts just like energy would if you were writing it as part of a chemical change. If it is an endothermic change, energy is acting like a reactant, and if it's exothermic, it's acting like a product. So if you increase the temperature in an endothermic reaction, your equilibrium will shift towards the products. And if you are adding a product, or sorry, adding heat and it's an exothermic reaction, it would shift back towards the reactants. And it would be the opposite if you're reducing the temperature. Pressure is going to be a little bit different. Sometimes you might add an inert gas that is not a part of your chemical system, and it would have no effect. And if you have equal amounts of moles of gases on both sides of your chemical reaction, you wouldn't see any effect either due to an increase or decrease in your pressure, which is typically caused by changing your volume. However, if you do have a chemical reaction that has a different number of moles of gases, and you decrease the volume, which would result in an increase in your pressure, you're going to shift the equilibrium towards the side with a fewer amount of gaseous moles, since you now have less space for them to occupy. If you have a decrease in your pressure, you have an increase in your volume, and you have a different amount of gaseous moles between the two reactants, between the reactants and the products, your equilibrium will shift towards the side with the greater number of moles. And so we'll look at a few of those on the next slide. So you have this decomposition reaction for sulfur trioxide. It's producing sulfur dioxide and oxygen. This is an endothermic reaction. Plus 197 kilojoules is your enthalpy for the reaction. And so if oxygen gas is added, oxygen is a product in this equilibrium system, or sorry, in this chemical system. So by increasing the amount of oxygen, you are causing the products to become greater, and you would need to shift your equilibrium to the left to balance out that increase in a product quantity. If you decrease the volume, which will result in an increase in your pressure, we need to look at the moles of gases that we have. All of our reactants and products are gases. We have 2 moles of reactants and we have 3 moles of gases. So if we're reducing the volume, we want to shift our equilibrium towards the side with a fewer amount of moles since we have less space, and that would be SO3, so that would be towards the reactants. If we add argon gas, argon is an inert noble gas. It has no effect on this equilibrium reaction, so therefore, or this chemical reaction, so there would be no shift in the equilibrium. If you reduce the temperature, you're reducing what's acting as a reactant, which means your equilibrium is going to shift towards that side that has now decreased, and that would mean that it too would shift to the left. Pretty sure I'm going to give you at least one that's going to shift to the right. And here we go. We're removing sulfur dioxide. Sulfur dioxide is a product, so you're decreasing the amount of sulfur dioxide that's present. So to reestablish equilibrium, your equation would, or your equilibrium system would have to shift to the right.